Hello, this video is going to go over operations with expressions. So when you are adding and subtracting polynomials, in other words, you are combining like terms, you want to make sure that you keep the base as is. We do not change the base. What we do is we only work with the coefficients. Those are the numbers in front. Also, when subtracting, don't forget to distribute the negative. I feel like this is something everyone knows, but as you're getting really tired of doing some math or you're rushing to get through these problems, a lot of people make the mistake of forgetting to distribute the negative to every single term inside the parentheses. Also, from goes first, which I will explain in a little bit. What's really important is that we always keep ourselves organized. So when you're multiplying polynomials, make sure you're using the box method or double distribution. Try not to do it in your head because that might lead to some mistakes. So let's try an example. For the first one, they want you to simplify in parentheses 3x squared squared. So what we are going to do is we are going to write our exponents. This is 3 to the first x squared. And then you distribute the exponent to everything on the inside. Remember, if you have a power to a power or an exponent to an exponent, you multiply. So we have 3 to the 1 times 2, x to the 2 times 2. That gives me 3 squared x to the 4th, which simplifies to 9x to the 4th. That kind of looks like a 4. All right. What is another way to do that problem? Well, you see, 3x squared squared means 3x squared times, sorry, my pen was bugging, 3x squared. We know that 3 times 3 is 9. And then x squared times x squared, when you're multiplying, you add your exponents. So this is going to be 2 plus 2. This is going to be 9x to the 4th. So you can see that you get the answer either way that you do it. Now, on the right-hand side, you cannot distribute the exponent. For simplifying in parentheses x minus 4 squared, you can't distribute that because they are different. Inside is a monomial. Inside, this one is a binomial. If you have a binomial or a trinomial, anything with plus and minuses, that means you cannot distribute the negative. Instead, this is x minus 4 times x minus 4. That requires the box method, double distribution, however you like to multiply. So I'm going to make the box. I have x minus 4, x minus 4. I'm going to write my exponents here. X squared times, sorry, x to the first times x to the first is x squared. X times negative 4, negative 4x. Negative 4 times x is negative 4x, and negative 4 times negative 4 is 16. You're going to combine your like terms. We have x squared. These two are the same, meaning they're both x to the first. So you keep the x to the first, and you add the coefficients. Negative 4 plus negative 4 is negative 8x plus 16. Let's try the next one. If f of x is defined as x cubed minus 4x squared plus 5x plus 2, and they give us g of x is x squared minus 2x plus 4. This is what we call function notation. They don't want to rewrite everything out multiple times, so they take the lazy route of naming the function. So f of x is found up here, and you're going to substitute. That means instead of writing f of x, you will write x cubed minus 4x squared plus 5x plus 2. Then g of x is over here. So we have x squared minus 2x plus 4. Now, I will admit, when you're adding, the parentheses don't actually matter. Anytime you have positive numbers, the parentheses are not as important. So instead, I'm going to rewrite it without parentheses, and you could jump straight to this if you would like. And we are going to combine like terms. So I see an x cubed. That is it. I'm going to write the x cubed. I'm going to go on to the next piece. Negative 4x squared and 1x squared. I'm going to keep the base, x squared, and add the coefficients. Negative 4 plus 1 is negative 3. Now I have the x to the first. I have 5x to the first and negative 2x to the first. Keep the base, add the coefficients. 5 minus 2 is positive 3. And then you have the pieces without any variables. Those are called constants. So 2 plus 4 is 6. This is different when you have to subtract. So when it says subtract g of x from f of x, from goes first. So we're going to put f of x first, and we're going to use parentheses. It makes a difference with subtraction. So we have f of x minus g of x. G of x in this problem up top says x squared minus 2x plus 4. Now that we have everything set up, the reason why the parentheses matter is because this is a minus 1 in front. You need to distribute the negative to everything, meaning this becomes negative x squared, positive 2x, and minus 4. The first thing doesn't change because there's a positive 1. And positive 1 times anything is itself. So we can ignore the parentheses for the first part. And now we're going to combine like terms. We have x cubed, negative 4x squared, negative x squared. Negative 4 plus negative 1 is negative 5x squared. 5x plus 2x is 7x. Constants, 2 minus 4 is minus 2. How are we doing? All right, these are little pieces on the regions. You're going to see them combined into more complicated problems, such as example 3. This was an actual regions question. So we're starting off with A times B. So here is A. Here is A. We're going to put it in parentheses. We have x cubed plus 2x minus 1 times B. Here is B. Here is B. We're going to keep parentheses. Actually, without parentheses, this is incorrect because when multiplying, you need to have parentheses around your expressions if they have more than one term. And then we are subtracting 3 times something. That something is C. My squiggles are not helpful, but here we go. So C is x to the 4th minus 5x. And I suggest you take it one step at a time, meaning we are going to multiply. Now we are multiplying something that is a trinomial times a binomial. I'm going to put it on the side because I'm running out of space. What is that? There we go. I have x cubed 2x minus 1. I'm going to put the plus there. And x squared plus 7. Now remember, when multiplying, you add your exponents. So 2 plus 3 is going to give x to the 5th. We have a 2, x to the first times x squared. Add the exponents to get x cubed. Negative 1 times x squared is negative x squared. If you like to keep the 1, great. 7 times x cubed, 7x cubed. 7 times 2, 14x, and minus 7. So we're going to take this and we're going to combine like terms. I see an x to the 5th. I see 2x cubed and 7x cubed. That's going to give me 7 plus 2 is 9x cubed. I see a minus x squared, a positive 14x, and a minus 7. So I have x to the 5th plus 9x cubed minus x squared plus 14x minus 7. I'm going to distribute my coefficient, and I'm going to get negative 3x to the 4th plus 15x. Great. Now that everything is multiplied and distributed, you just have to combine like terms. I see an x to the 5th. I see 9x. Ooh, no. The next thing I see is negative 3x to the 4th. Then I see a 9x cubed. There is a negative x squared, and be careful with the 14x because I actually see a 15x as well. So you're going to keep the base, which is x, combine your exponents to get 29. And then for your coefficients, that is the only one, your constants, sorry, I only see a minus 7. So there wasn't that much combining like terms to do. You just had to put your exponents in descending order because it says standard form. So when it says standard form, you must start with the largest exponent and end with the constant. Otherwise, you will lose a point. Anyway, I hope that this video helped, and now you could try some examples on your own.